Alright, so we're going to be doing the pH and protein function lab today. So you should all have this down in your lab notebook. You should have your pre-lab done. So you should have already written out what your hypothesis is, what your variables are, and what your control is. In addition to that, you should probably copy your methods into your lab notebook. And pay particular attention today. As we go through this, there are going to be times when you might want to pause the video and make a record in your lab notebook of changes that I've made, because I'm going to make several changes along the way here, and you need to pay attention to those changes and get them recorded in your lab notebook. In addition to recording that in your lab notebook, you're going to be actually viewing the data today. So you're going to actually record the data as I build the data, as you get the data. We're going to have test for starch in these multi-well plates, these depression plates. There'll be iodine and our reaction solution in each of these wells. You can see I've labeled them 4, 5, 6, 7, 8, 9, 10, and our control. Okay, and you're going to have to record what colors you see in each of those wells. So make sure that you keep track of all of that. The first step is I'm going to add my pH buffers that are going to hold the pH at a specific level to each of my tubes, and I've labeled my tubes accordingly. I don't know if you can see that. This one's labeled 4 for pH 4. I'm going to be using this device, which is an electric pipetter, and it has two buttons. One of the buttons, the top button, draws the solution up. The bottom button dispenses it. I'm going to be using a different pipetter for each different pH solution, so there's no cross-contamination. So you can see how this fits in there. There's my pipette, and I'm ready to get started. So this is going to take a little while, but we can talk while I do this. 2.5 milliliters of each pH buffer into each tube, including my control. So we're going to be talking about what the control is and what it controls for in lecture. In our Zoom lab meeting. And for the record, for our control today, I'm going to be using a pH buffer of 4. But the pH isn't what makes it a control. So you should be thinking about what it is that a control does. What is a control good for? Whenever we use a control in our experiments, the purpose of any control is to make sure that we're actually measuring what we think we're measuring, that our system is designed correctly to measure what we want to measure. What we want to measure in this lab is the function of amylase. So we have to make sure that that's actually what we're measuring. So think about your control. We'll talk about that in our Zoom lab meeting. This is pH buffer 6. Make sure I get it in the right tube. For the record and for your lab notebooks, I have tested the pH of all of these solutions, and they are accurate to within 0.01 pH units. pH 7. pH 8, pH 9, and pH 10. Almost put it in the wrong one. Alright, there's our pH buffers. Next, we're going to add 2.5 milliliters of the starch solution. So, here's our starch solution. I'm going to get a fresh pipette for this. So, because I'm adding starch to each one of these tubes, as long as I don't touch the pipette to the solution in the tube, I can use the same pipette for all of these. And these pipettes that I'm using will allow me to draw up 7.5 milliliters, so I can dispense 2.5 milliliters to 3 tubes with one draw. So I'll show you how that works. So I'm going to draw up 7.5 milliliters. Go to my first tube, dispense 2.5 milliliters. Now I have 5 left in my pipette. 2.5 more. And the last 2.5 milliliters in the third pipette, in the third test tube. I'm going to repeat that again. Now, I have 2 more tubes to add to, so I'm only going to drop 5 milliliters this time. Two and a half milliliters into this tube. 2.5 milliliters into this tube. Alright, so we got our starch, we got our pH buffers. The last thing we're going to add is our amylase solution. And this is going to be a change, so you may want to pause it after I tell you this to enter it into your lab notebook. I'm going to be adding 2 milliliters of amylase solution. So I had my amylase sitting on ice while I prepared everything else, and I just made that up fresh today. So why do I keep it on ice before I'm ready to use it? Think about that question. Alright, so 2 milliliters of amylase. So I'm going to draw up 6 milliliters, like I did with the starch. I'm going to draw up 6 milliliters and then dispense 2 milliliters each to the first 3 tubes. I'll repeat that. For the next 3 tubes. Now I'm just going to draw up 2 for my last experimental condition. And 2 milliliters of distilled water in my control. Noted that my control had distilled water instead of amylase in it. Why did I have to add the distilled water? So I just covered this in parafilm and mix it up, set it to where it start my time. Okay. Second one. This is parafilm. It's kind of a waxy, stretchy substance that you can stretch over the top of a tube, and it creates a seal. And you want to make sure they're well mixed so that the enzyme has access to all of that starch. So it's going to do something. It's got access to the starch to do it with. This is my pH 10. And finally, my control. All right, so we're off and running. If there's going to be a reaction between the amylase and the starch, it should be going on right now. I've started my timer, so I will come back in 5 minutes, and you'll see me test for starch at the first time point. Okay, so our 5 minutes isn't quite up yet. I'm going to show you how we're going to set up the assay for starch. First of all, we have these depression plates that I've pre-labeled with the pH. You should be able to see that is labeled starting over here 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm sorry, 10, 11, 12. 10, and then our control. So we have to add 20 microliters, and I'm going to be using this micropipetter, and we'll talk more about this in the next lab, but it's set for, I don't know if you can see this, it's set for 0.020. That's 20 microliters. Put on a disposable tip. So I have my iodine right here, and I'm going to aliquot 20 microliters of iodine into each well. Notice I'm using the same pipette tip for each one, because again, all I'm doing is touching iodine. I don't have to worry about cross-contamination. And the tips are disposable. So now checking my time. Looks like we're 5 minutes right now. So I'm going to start testing my reaction solutions. So I've got pH 4 here. I'm going to take 20 microliters of pH 4 reaction solution, put it into the first well, give it a little stir. Notice I'm changing tips now, because with each reaction solution I don't want to cross-contaminate my reaction solutions. Taking another 20, the next well, stir it up a little bit. Mixing the reaction solution before I sample it. pH 6. Now it's important that you all record the colors of this today, because I'm colorblind and I would not be a reliable source of information. pH 8. pH 9. pH 10. Notice I give it a little stir with the tip before I go on to the next one. And finally, our control. So can you see those colors? The upper left is 4, 5, 6. Second row is 7, 8, 9. Third row is 10 and control. All right. Wait for the next time point. All right, it's almost time for our next time point. So I'm going to aliquot my iodine. This will be our 15-minute time point. Checking the time. Got another few seconds to go. And that's 15 minutes. And our pH 4 reaction solution. pH 5 reaction solution. 6. Page 7. Page 8. Page 9. Page 10. And control. And there's your data. Time point 15 minutes. Again, top right is pH 4, 5, 6, 7, 8, 9, 10, and our control. And I'm going to go get this cleaned up so that we're ready for our last time point. All right, our last time point. I'm going to aliquot my iodine. So remember, starting with pH 4 here, so remember that when starch meets iodine, it turns purple. And if there's no iodine, if there's no starch present, it stays more of that ambery brown color. In this case, it looks more yellowy. pH 5. Now, you might notice in some of these wells, the liquid is a little more spread out, and in other wells, it's a little more beaded. That can affect the color density, making it appear either lighter or darker, but it'll still be either light or dark purple if there's starch present. But you really get to see a more yellowy brown when starch is absent. Here's our pH 7. Interesting. pH 9. pH 10. And finally, our control. I'm going to go for another 5 minutes because I've seen another change here. So there's our data. Record those colors. Again, upper right is 4, 5, 6, 7, 8, 9, 10, and control. Alright, I'm going to go wash this out, and I'm going to take it out for another 5 minutes because I noticed there seems to be a change in pH 8 all of a sudden. All right, we are at time point 25 minutes, and I took it out an extra 5 minutes because I thought I saw some changes that I hadn't seen prior to that. I've already aliquoted out my iodine. I didn't think you needed to watch me do that yet again. So now I'm going to add, for the last time, guaranteed, my reaction solutions. Here's pH 4. And again, like I said before, in some of these wells the solution is more spread out, and in some wells it's more beaded up. But the colors may look lighter or darker, but if it's a good purple, that means starch is present, even if it may look a little lighter because the solution is a little more spread out. Here's our pH 6. That looks a little different. pH 7. pH 8. Yep. pH 9. pH 10. And our control. All right, this is our last time point. Again, time point 25. Here's your data to record. It's all in the same order as it was before. And that will conclude our lab for today. If you have any questions, always email me. That's the best way to get in touch with me. We can set up a Zoom time to meet, whatever's necessary. So please feel free to get a hold of me. But now you have all your data recorded in your lab notebooks. You should be ready to go ahead and write your draft pH and protein function report. So again, consult the lab manual, consult the section on how to write a lab report, consult the section, the actual lab rubric, and the explanation of the lab rubric, all of which you can find online, at least links to in this second module. Okay, those will help you figure out what to put in each section, including the title and the literature cited section. So if while you're reviewing all of that information you have any questions, again, please get a hold of me. Thank you very much. See you later.